For today's lesson, this is Chapter 1, Lesson 2 of your math book. We are going to, I'm just reading the objective at the top, so if you want to follow along, we are going to add, subtract, multiply, and divide rational numbers. Let's first talk about what rational numbers are. Rational numbers are any number that you can write as a fraction. So all fractions are rational numbers. All decimals are rational numbers. All whole numbers are rational numbers, like 0, 1, 2, 3. All negative numbers are also rational numbers. So -1, -2, -3, those are all rational numbers because they can all be written as a fraction. All the numbers you've learned about from kindergarten until this point have included rational numbers. So this is basically a review lesson for you on adding, subtracting, multiplying, and dividing all numbers that are rational numbers. So example 1, evaluating numerical expressions, is giving the value of a number expression. Remember, please, from your vocabulary that an expression is a number sentence without an equal sign. So for example, 26 plus 8 is a numerical expression. 22 times 10 is also a numerical expression. So we're going to, for example 1, letter A, we're going to evaluate the expression, in other words, give the value of it, and then we're going to describe the result in words. So let's get started. For example 1, letter A, the expression is 124 plus 82. Notice that there is no equal sign. That's what makes this an expression. The value of this expression is 206. And then putting that into words, the sum of 124 and 82 is 206. What I'd like for you to pay particular attention to here is some vocabulary. Notice that when we have addition here, we have the word sum here. So we use the word sum whenever we're talking about the value of an addition problem. Let's move on now to letter B. However, before we do that, you need to go ahead, give me 1 second here, there we go. You need to go ahead and write all of this down in your notebook. So please make sure you have this written in your notebook. Let me move this out of your way. Okay. You need to write the objective at the top of the page. You need to write example 1 and evaluating numerical expressions. You need to write everything that is under it. Why don't you go ahead and pause the video now, write that down, and then when you're ready, press play again. Moving on now to example B. Example 1 still, we're still on example 1 doing the same thing, but moving on to another one, another expression, letter B. We have 0 and 45 hundredths minus 0 and 39 hundredths. So this is the expression. Again, it's an expression because as you can see, there is no equal sign. So let's evaluate the expression, give the value by subtracting, and we get the value of 0 and 6 hundredths. And then let's put that into words. To put this into words, we would say the difference of 0 and 45 hundredths and 0 and 39 hundredths is 0 and 6 hundredths. So now again, I'm going to ask you to pay particular attention to that vocabulary. So as you can see, this is a subtraction problem. When we have subtraction, we use the word difference. So make sure you pay special attention to that when we have subtraction, we use the word difference. Next, I'd like you now to write this down. You no longer need to write the objective. You have it at the top of the page. It's the same objective. It didn't change. Since example 1 also did not change, we're still working on evaluating numerical expressions. There's no need to write that again. So the only thing you need to write again is anything below the blue line, and I'm going to make a blue line for you. So all I want you to do is write anything below the blue line. You can go ahead and pause the video now, write letter B and everything that's with letter B, and then press play again when you're ready. As you can see, we are still working on example 1. We've moved on to letter C now. So the next expression we're working on is 6 times 12. First, we evaluate the expression by giving the value of it. The value of 6 times 12 is 72. And then we put it into words. The product of 6 and 12 is 72. Again, of course, I'm sure you can tell now by the pattern here, I want you to pay special attention to this vocabulary. So we're looking at the operation, which is multiplication, and the word that we use when we're talking about the value of a multiplication problem is product. So what I want you to do now is I want you to go ahead and pause the video again. I want you again to write everything down that's below the blue line. I'll make a blue line for you. Again, you do not have to write the example or objective again. It's all the same. I'll let you know when it changes. So right now I just need you to write letter C under where you wrote letter B and write all of this information. Go ahead and pause the video and press play again when you're ready and have all of this written down. Okay, so this is the last one for example 1 that we're going to do. This is letter D, and it is 8 1/10 divided by 0 9/10. This is the expression, and we're going to give the value of this expression. The value of 8 1/10 divided by 0 9/10 is 9. If you're not sure how I got 9, be patient and wait. When we go over some of the guided practice at the end of this lesson, you will see how that's done. So, the value of 8 1/10 divided by 0 9/10 is 9. Now let's look at the words. How do we write this? Again, last time here, paying attention to the vocabulary. For division, when we have a division problem, we are going to use the word quotient. So, division, quotient. Again, make sure you remember this vocabulary. So just to review with you quickly, this vocabulary that's very important for you to remember is, we use the word sum when we're talking about addition. We use the word difference when we're talking about subtraction. We use the word product when we're talking about multiplication. And we use the word quotient when we're talking about division. And those are the 4 operations of math. So I need you just to remember those 4 operations and the 4 vocabulary terms we use when we're talking about the value of each of those operations. Go ahead and pause the video here, and you are going to again write in your notes everything below the blue line for letter D. Now moving on to example 2. Again, it's the same objective throughout the whole lesson, so you never have to write the objective again. You only write it once at the top of your page. But now what you can write under where you wrote letter D, all that information, now you can write example 2, evaluating variable expressions. And you can also go ahead and write letter A, evaluate 5n when n equals 6. I will go ahead and wait for you to write that. You can press pause on the video and write that first. And now we will move on solving this. A couple things I want to point out here. 5n. When you have 5n here, let me get my marker out because I want you to focus on this. There. Make sure you're paying special attention to that 5n there, okay? What that means is anytime you have a number right next to a variable, n is the variable, it means multiply every time. So every time you see this, you need to think in your head 5 times n. 5 times n. Okay? All right. So, over here, n equals 6. If n equals 6, that means that n and 6 are the same. There's no difference between them at all. N is 6. That's the value of n. It is 6. The reason that I'm telling you this is because you will use a lot of substitution in pre-algebra this year. So we need to make sure right from the beginning that we understand this and that we know how to substitute a number for a letter, variable, when we have an expression or an equation. Okay? Let's get started on this one then. Since n equals 6, what I know here is that the value of n can be replaced with the number 6. So I'm going to, just as it says here, substitute 6 for n. Now if I were just to put 6 where the n is, like this for instance, as you can see, I would have the number 56. But that's not what it means. We can't do that because we're changing the value then, and that's not what we're here to do. 5 times n, not 5n, 56. So we have to be very careful here, make sure we multiply. This is why you see here the 5 next to the 6 in parentheses. So, not like that, but like this. So 5 times 6, parentheses, anytime you see a number next to parentheses, that also means multiply. 5 times 6 is what you should be thinking in your head to solve this problem. So now that we've used our substitution, we can go ahead and give the value. 5 times 6 is 30. This is called simplifying. It's called simplifying because you are simplifying the term, or the factors, I should say, 5 and 6 into one digit 30, or one number. Okay. So go ahead and write this down for letter A. You do not have to write the 56 there. As a matter of fact, I will go ahead and erase that for you. So, okay. Just write down everything that you see here, pause your video, and we'll move on to the next one when you're ready. Okay, this is the second one, letter B. Evaluate x plus y when x equals 2 5/10 and y equals 1 4/10. So you're going to give the value of x plus y. And first, of course, just like you did before, we're going to substitute. So instead of writing x, we're going to give the value of x, which is 2 5/10. So we're going to write 2 5/10 in place of x. We're adding, so we go ahead and write the addition symbol here as well. And then we're going to replace the y here with the number that y is, which we see here. Y is 1 4/10. So we're replacing y with 1 4/10, which is what we've done here. That's your first step, substitution. Next, we value that. 2 5/10 plus 1 4/10. Focusing again on your expression here. So 2 5/10 plus 1 4/10 is 3 9/10. Okay. So the value is 3 9/10 of 2 5/10 plus 1 4/10. Go ahead and pause your video, write down this example, and when you're ready, press play. We'll move on. Okay, you are now ready for guided practice. What you'll need to do here is pause the video, write down the problem, and then play the video to hear how the problem is done. This is practice where I help you along. Tomorrow you will do some independent practice in class, meaning that I will be here to answer questions for you while you practice. However, I will not be guiding you the way that I am right now. So, for guided practice number 1, are the parts of the expression 32 times 5 2/10 called terms or factors? What they mean by parts is they want to know if the vocabulary that we would use for the numbers 32 and the number 5 2/10, would we call those two numbers terms or factors? This is review for you from last year and the year before that, actually, 5th and 6th grade. Terms are what we call numbers when we're adding or subtracting. Factors are what we call numbers when we're multiplying. Since this is a multiplication problem, the term we would use is factors. So your answer is factors. Make sure you pause the video and write all of this down, including the answer. Also, please make sure, just to make sure you're in the habit for any work at all for me, that you box your answer. So you should always be boxing your answer like so. Make sure you skip a line when you write number 2 to keep this all nice and neat. So pause, go ahead and write it, and then we'll move on. Number 2. Are the parts of the expression 112 plus 96 called terms or factors? Again, make sure you write number 2 down. And now, since this is an addition problem here, these numbers 112 and 96, 112 and 96, those are the parts they're talking about. So those are the parts. They want to know if these are called terms or factors. Well, since this is addition, the numbers 112 and 96 are now called terms. And again, please make sure that you box your answer when you write it. Go ahead and pause the video, press play when you have all this written, and we'll move on to number 3. Solve for the expression and use math vocabulary to give your answer verbally. So 28 plus 40, first we're going to solve. 28 plus 40 is 68. And now we're going to write our answer verbally. So, again, you see addition. If you can remember, what was the vocabulary we used for addition? Okay, if you said sum, or if you thought the word sum, then you were correct. So we would write the sum of, and then write the terms, 28 and 40 is, and give the value, 68. Let's check our answer, see if we got that one right. So the answer is 68. That's the value. And then the words are, the sum of 28 and 40 is 68. So make sure you have all of this written down. Make sure your answer is boxed again. Always boxing your work. And then we'll move on to number 4. Using the same directions now, we're going to give the value and then write it in words. 63 divided by 7. This is a math fact, so you shouldn't have to do long division here. 63 divided by 7 is 9. So now using our words, we have division. So for division, the word we use is quotient. So we're going to write a sentence using the word the quotient. The quotient of 63 and 7 is 9. And we'll check our work. Good. And we'll box our answer. Again, pause. Make sure that you have all of this written down. Oh. Okay. And let's move on to number 5. Now we have a subtraction problem. Remember, the vocabulary for subtraction is, hopefully you were thinking difference. So let's find the difference. Now this may be easier for you to write subtraction of 2-digit numbers in vertical form instead of horizontal. So we can rewrite it 40 minus 27. Borrow from the 4. 10 minus 7 is 3. 3 minus 2 is 1. The value is 13. In words, that would say the difference of 40 and 27 is 13. We'll check our work. Good. And box our answer. Moving on, you can pause this every time to make sure you write it all down. Moving on to number 6, 12 times 4. We're going to give the value. 12 times 4 is 48. And we're going to write this in words. Multiplication means product. So we have the product of 12 and 4 is 48. And we'll check our work. The product of 12 and 4 is 48. Good. Number 7. 90 minus 7. Again, subtraction is difference. So 90 minus 7. Borrow from the 9. Make this 10. We have 83. So our answer is 83. And the difference of 90 and 7 is 83. Check your work. Perfect. Box your answer. And number 8. 111 divided by 3. I'm going to go ahead and use long division on this. 111 divided by 3. 3 does not fit into 1, so we divide 3 into 11 3 times. 3 times 3 is 9. 11 minus 9 is 2. Bring down the 1. 3 goes into 21, now 7 times. 3 times 7 is 21. Subtract, no remainder. So the value is 37. And again, division is quotient. The quotient of 111 and 3 is 37. And we'll check our answer. And number 9. 13 times 6. 13 times 6. 6 times 3 is 18. Carry the 1. 1 times 6 is 6 plus 1 is 7. 78. The product of 13 and 6 is 78. Check our answer. The product of 13 and 6 is 78. Number 10. Now we have 3 terms in this problem. The terms are 7, 5, and 8. So, we'll take these two first. 7 plus 5 is 12. Bring down the plus 8. 12 plus 8 is 20. And these are all additions, so we can say sum for all of them. And list all the terms of 7, 5, and 8 is 20. Just because we've added another term, the approach has not changed. We're still doing the same thing. Using the operation that we see to add, and then writing it in terms of words, using the vocabulary for addition of sum. Number 11. Now this changes a little here. They're going to tell us the words, and we are going to write a problem and give the value. So if you remember, what does sum mean? Think about what sum is. Sum is addition, right? So here's my special word, meaning addition. So I know I'm adding the terms 15 and 33. So 15 plus 33. And when we add those together, we get 48. Box your answer. 15 plus 33 equals 48. The product of 20 and 7. Again, product means multiply. What numbers am I multiplying? The factors 20 and 7. 20 times 7 is 140. So this is my answer, 20 times 7, 140. I have the expression as well as the answer. And number 13, difference. Difference is subtraction. So the difference of 18 and 9 is 9. There's my answer. 18 minus 9 is 9. Number 14, the quotient. For quotient, we have division. And there are many ways to write a division problem. So, division, 360 and 9. I just want to show you another way to write this. 360 divided by 9. Either one of these would be correct. And 360 divided by 9, again, this is kind of a math fact, so I'm going to show you 2 ways of doing this. 1, cover the 0 with your hand or with your finger on the screen and divide 9 into 36. That's a math fact. 9 goes into 36 4 times. Now put the 0 back on. And the answer is 40. The other way to do this is, of course, to use long division. 9 into 360. 9 goes into 36 4 times. 4 times 9 is 36. Subtract, bring down the 0. 9 goes into zeros 0 times, and again you get the same quotient of 40. So this would be your answer. And 360 divided by 9 is 40. Number 15. Now we're using variables. Okay? This says to evaluate the variable expression when n equals 3. So for number 15, we know that 3 with a variable next to it means multiply. So this means 3 times n. I'm first going to use substitution. So I'm going to substitute the n here with the number that it equals, and that is 3. So I'm using these parentheses to show multiplication. Without the parentheses, it would just say 33. But that's not what we want to do here. We want to multiply. So 3 times 3, this is substitute. That's my first step. And now I simplify by actually multiplying. 3 times 3 is 9. So there's your answer of 9. Number 16 is the same thing, using variables. So think. I put a little guy up here that tells you think. N is 3. So you're substituting the variable n in the expression for the number 3. So instead of writing n here, we're going to write the number 3 plus 20. Everything else remains the same. And now we're going to give the value of that. What is 3 plus 20? The answer is 23. 23. And number 17, again substituting. N is still 3. We're not changing the value of n. It's still 3, so we're substituting the number 3 in here. So instead of n here, we're going to substitute the number 3. So again, sub. Don't forget we're subbing. Just like sometimes I have a sub, right? When I'm not here, there's somebody to take my place. So imagine that we're getting rid of that n and we need something to take its place. Well, the directions up here tell us what should take its place. This tells us that 3 should take its place. So everything else remains the same. 3 minus 2, the value is 1. So the value is 1. Number 18. N is still 3, so we're still substituting n for 3. And this time we're adding 0. 3 plus 0 is 3. So, 3. Number 19. N equals 3. 3 is being divided by 1. So we're going to substitute the n for 3. Again, that's substitute. Every time, don't forget that word. That's a good one for all year for you to remember. Substitute. Divided by the number 1. Well, 3 divided by 1 is 3. So this is my answer, just 3. And good, we're correct. We're almost done. We just have a couple more. Number 20. Again, a division problem. Substituting the n for what number? Yes, 3. Substituting for 3. Again, I'm just going to keep writing this word so that we just don't forget. We're using substitution. Substitute, substitute, substitute. And everything else remains the same. 3 divided by 3 is 1. Your answer is 1. And number 21, sorry. 18 divided by n. So 18 divided by, and here's where we substitute. Instead of n, what number do we write? Still 3. So this is where I substituted this time. You don't change the problem. You always substitute exactly where it tells you to, and the variable here is what tells you where to substitute. So 18 divided by 3 again is a math fact, 6. And we're correct. The answer is 6. Last one, number 22. 100 minus n. 100, I'm not going to change. I'm going to substitute, though, the n for the number, you guessed it, 3. And now 100 minus 3. Some of you may be able to do that in your head and just write the value of it here. Others of you may have to write it in long form and use the borrowing. So we'll do that. Borrow from the 1, make this one 10. We still don't have enough here to subtract, so we need to borrow from the 10, make it 9, and make this 10. Now we have 10 minus 3 is 7, 9 minus nothing is 9, and 0 we don't need to write, so the answer is 97. 97. That's it for today's lesson. Be prepared in class tomorrow to do more problems with subtracting, adding, multiplying, and dividing rational numbers. You guys have a great night.